Remember way back in second unit. Okay, don't look it up now. Second unit, we did transformations, right? And we had that very big equation that was this, AF BX minus H plus K. Yes, we all remember that? Okay, now, A and B were what? What's A? Vertical stretch. What's B? Horizontal stretch. It moves it in and out. What does H do? Left to right, and K goes up, down. So you're experts. Now, F stood for any function, correct? Yes. Okay, we're changing those functions to trig functions. So sine and cosine. The other thing they do, just because it's math, all right, is they don't call them H and K anymore. They call them C and D.
Why?
I don't know. All right, it doesn't matter. The variable is irrelevant. It's its location. And it's a little more natural, A, B, C, D. That kind of makes a little more sense. Okay? So A does the same thing. You get a vertical stretch. B does the horizontal stretch. C moves it left to right. It's called a phase shift, if you want to be particular. And D moves the graph up and down. It's the exact same thing. So the first part we're going to do is just tell me what has happened. What is the transformation we have done? So we're starting with y is equal to sine x. I have this 2 sitting in front. What has that done? Vertically stretched. So a is equal to 2. Therefore, it's a vertical stretch by 2. What about the next one? Is that an A or a B? B. B is equal to 2. What does that do?
Horizontal compression?
So it's a horizontal stretch by 1/2, which is a compression. All right. So it actually takes the graph and it accordions it. Okay. And that's going to have implications later on. Next one, A or B? A. Now A is -3. What does the negative do? Over. So flip over x-axis. And what?
Stretch by 3.
Vertical stretch by 3. Sine of -3x. A or B? B is -3. All right. What does the negative do? Flip over y-axis. And the 3 does a vertical, sorry, not vertical. Does a horizontal stretch by 1/3. That is a compression, yeah. All right. Are we okay with that? Okay. Which of the examples here will change the amplitude of the graph, i.e., whoops. Yeah. So there's our sine graph, which is going to change the height. It's going to be 1 and 3, i.e., I'm just going to write the A value. It's the height, right? The height that it goes to. You were right. You were correct, Jackson. Jackson was correct. You are now immortalized in the internet, on the internet. All right. There you go. And no. Which of the above examples is there a change in the period? So what is going to change the period? Now, what is the period of a graph? Yeah, so one complete cycle or the graph peak to peak. The only thing that's going to change the period is if you move it this way, okay? So that's going to be the B values. Okay. So, all right. Okay, this table. So we've got the sine graph right there. What is the amplitude of a straight up, regular, no nonsense sine graph? 1. What is the period of a no nonsense sine graph? In radians, we'll do it in rods. 2 pi, right? 360 degrees. Or 2 pi. You were right. I just want it in rads. Or I'll say 360. We'll do them both. Okay. If I put the 2 in, so this, we said, these are the same ones up here. That's going to be a vertical stretch by 2. So that is going to take my sine graph, say this one, which is at 1 and -1, and it's going to stretch it vertically by 2, right? So where are the peaks going to be now? Yeah, so the graph just looks like this, right? -2 and 2. So what's the amplitude? 2, right? Because it's you add them, or sorry, subtract them and then divide by 2. All right. Does the period change? No, it doesn't. So it's still 2 pi. Okay. Let's do all the a values first. So if I do -3, what does that do? Flips it and stretches it, right? What's my amplitude? 3. What's the period? 2 pi, didn't change. Nope. The negative just tells you you've done a flip. I don't know who asked that question, Talia. The negative just tells you you've done a flip, and you remember yesterday, amplitude is equal to max minus min over 2. So we would still get a positive number. Okay. Okay. So let's look at the b values now. What does that do? Does that change the amplitude? No, the amplitude is still 1, right? Okay, it's going to change the period. By how much? What does the 2 do?
The 2 compresses it
by a power of 2. So if you have a cosine graph, or sorry, a sine graph that looks like this, and that's 360, and I shrink it by half, where does this point move to? 180. So what's the period? Pi, or 180. There you go. So what does the -3x do? Or the -3 in front of the x, this one? So it's the amplitude will stay the same, and it's gonna cut the period by 1/3, or 3. So what's the period gonna be? 2 pi over 3. All right, next one. What's the amplitude? 5. What's the period? That's right. You could go 2 pi over 4, which is pi over 2. What's pi over 2? In degrees, sorry. 90 degrees. No, it's going to depend on the question. Yeah. Okay, next one. Y is equal to 1/3 sine 1/2 x. What's my amplitude? 1/3. What's my period? 4 pi, right? Because it's going to be 2 pi divided by a half. What do you do when you're divided by a fraction? Because that's actually a horizontal expansion by a factor of 2. So it's 4 pi. What is 4 pi? 720. All right, so what is the formula for amplitude if I have y is equal to a sine bx? But do we use the negative? So we're going to say the absolute value of a. Okay. And what about the other one?
Would be 1 over the absolute power, or absolute value p.
Times?
Pi. Oh, sorry, 2 pi over the absolute value p.
There you go. You don't have to apologize. Because the negative just tells you that you've done a reflection, right? That won't actually change the period. So it's 2 pi over the absolute value of b. If you flip to the next page, you'll get a big table right there. Well, it's 3 things. It's not really that big. We're going to make it bigger tomorrow. So, for sine and cosine. Now, you can either remember these things or write them on your formula sheet. Up to you. Amplitude is equal to the absolute value of A or max minus min over 2. You use the max minus min over 2 when you have a graph. Use the absolute value of A when I give you an equation. Okay? That's for an equation. So sine and cosine are straightforward. They're the exact same formulas. Tan is where people get messed up because, and it has to do with the period. Period for sine and cosine is 360 over b or 2 pi over b. Absolute value of b. Okay? But you remember the tan graph has a period of 180 degrees. So if you're going to shrink it or stretch it, it's 180 divided by b or pi divided by b. Like if I give tan of 3x, 3 is your b value. And the amplitude for a tan graph is not applicable because you don't have a max or a min. However, I can write this 2 tan x, I can say, what is your a value? And you would tell me it's 2. If I said, what is the amplitude? You would say not applicable or infinite. Does that make sense? Because there's no max or min on a tan graph. Okay? You got a sticky note. If you can fit it on your sticky note, we're going to add to this table. It's going to get bigger. Okay? No, on your test, you get a sticky note. Do you want one right now? You want to start building your sticky note right now? Well, they're up at the front. No, they're not up the front. All right. I need you to do questions 1 to 4, please. And that'll bring us up to the end of the day.